The diagram represents a square wave phase. For a square wave, if you want, you have to take the identical point. Like if I take this point, any of the point you can take. So what is one vibration when we reach the same identical point? So this is one vibration. This is second vibration. This is third vibration. This is fourth vibration. Fifth vibration, sixth vibration, and approximately seven vibrations are there. Because, or you can also, like this is seven vibration, you can take, if this is your start, you took this as a starting point, one vibration, this is one vibration, two vibration, three vibrations, four vibration, five vibration, six, seven. Approximate. So how many boxes are there? One, two, three, four, five boxes are covering this, and the time base is 10 millisecond. So means the each box is representing an interval or a duration of a 10 millisecond. This is 10, 20, 30, 40, and 50. So means total is 50 milliseconds. But if we need a frequency, frequency is reciprocal of the time period. First, we need a time. How many vibrations are there in 50 millisecond? This is 1, 2, 3, 4, 5, 6, and 7 vibrations are there. So if I need the time period is the total time divided by number of the vibrations. So that should be 50 divided by 7. So what is 50 divided by 7? But if I need a frequency, frequency is reciprocal of the time period, so it will be 7 divided by 50. And milli means what? Milli means 10 raised power minus 3. So if it is 7 divided by 0.0, like 50 exponent minus 3, so we got B as the right answer. So we want, because we know the spacing between the, we have to change a millisecond into the second. Because it was written 10 millisecond, I have converted into second, because it was like 50 millisecond over second, and I got second divided by 50 into 10 to the power minus 3. I wrote that. So that's why we are getting 140. In this question, the diagram shows a trace of a wave on a CRO, cathode ray oscilloscope. The vertical and horizontal grid lines have a space of 1 centimeter, and the voltage scale is 4 volts per centimeter. So what is an amplitude? And what is the period, time period? You can use the chat to answer. So amplitude is a half of the distance between the two extremes. Like if I take this is the total vertical distance, so half of this will be the amplitude. What is the total vertical distance from one peak to another? That is 3 boxes, and each box is representing 4, because it is written y-axis 4 volts. So this will be 4, this will be 4, and this will be 4. So total is 12. But we need amplitude. Amplitude will be half of the distance from one extreme to another. So it will be 12 divided by 2. That amplitude will be 6. What about the period? The time period, the time it takes for a one complete oscillation, that is known as the period. So if this is one peak and this is another peak, so how much time interval? So 1, 2, 3, 4 boxes are there, and on x-axis, each box is representing 5 milliseconds. So this will be 5, 5, 10, 15, 20. So that time period will be 20 milliseconds. So 6 and 20. So C should be the right answer here. Is it clear to everyone? How we worked out the amplitude
Sir,
and the
sir, can you
period?
explain again? I'm confused.
Sure, I will repeat. amplitude of the wave is refers to the distance, half of the distance, or a distance from mean position to extreme position. That's called an amplitude. So if I need an amplitude of the wave, if I take the distance, the vertical distance from one extreme to another, and I divide that by 2, so I'll get a half distance. And when I get this half distance, what I will get? This will be an amplitude. So what we did, this is one extreme and this is another extreme. So what is the distance, the vertical distance from one extreme to another? How many boxes it covered? It covered 3 boxes. So 3 boxes are covered from one extreme to another. Now, according to the voltage scale, that it is 4 volts per centimeter, means one box or 1 centimeter representing 4. So this is 4, 8 and 12. So the 12 volt is the total vertical distance from one extreme to another. But what we need a half of it. We need an amplitude. So what we will do, it will be 12 divided by 2. That is equals to 6 volt. So we wrote the amplitude to be a 6 volt. What about the time period? The time period, time to complete one oscillation or time taken by one oscillation. So, or one oscillation can be from one crest to another or one trough to another. So if I take from one crest to another, the distance, the interval is known as the time period. So according to the scale, they mention the time scale, it's 5 milliseconds, 1 centimeter. Like if you complete one box, it is equivalent to 5 milliseconds. So this is 5, 10, 15 and 20 milliseconds because each box is 5. So this is 20 milliseconds. And that is what we need, the time period. So the time period will be 20 milliseconds. If I take a base as well, so it will be 1, 2, 3, 4 boxes are there. So again, it will make 20 milliseconds. Is it clear? Or I take this as one oscillation. If I take one complete crest, another complete trough, this is one oscillation. So how many boxes it cover? It also cover 4 boxes. So that also make 20 milliseconds. But because the crests are easy to identify and on the CRO cathode ray oscilloscope, if it lie on the grid, it makes it much more easy to recognize. That's why we prefer the grid here. Like we prefer the peaks or the crest or the trough. Is it clear now?
Yes, sir.
The diagram shows an experiment used to measure the speed of a small ball which is falling at a constant speed. And there are 2 markers on the tube. The top marker is positioned as 115 plus minus 1 millimeter, that is the uncertainty. The lowest marker is 285, which is plus minus 1 millimeter. The ball passes from a top and with an uncertainty of 0.02, and the bottom marker is 3 when the time interval is 3 and with the uncertainty of 0.2. The constant speed of the ball is calculated, which expression calculate the fraction of the uncertainty in the value. Like how we will get the uncertainty, the fractions of the uncertainty. It is a very straightforward question. Remember, uncertainty always add. Even you're subtracting the two quantities, you're dividing the two quantity. When we are dividing, we add the percentage uncertainty, but we are subtracting or multiplying, then we also add percentage uncertainties. But the thing is, whenever we need the fraction of the uncertainty always add up. So which expression shows a fractional uncertainty in the value of this speed? The speed was like 270 divided by 2, which was about 135. So what was the uncertainty? Basically, if speed is calculated by distance over time, distance will have a different unit, time will have a different unit. But if I need the percentage uncertainty in the value of a speed, so I need the uncertainty or the percentage uncertainty in D, plus I need the uncertainty or the percentage uncertainty in T. And percentage uncertainty is uncertainty divided by the value recorded, and this also uncertainty divided by value recorded. We just need a fraction, that's why it is not multiplied by 100, as they just asked which expression calculate the fractional uncertainty. They did not say percentage. Fractional uncertainty is just the uncertainty divided by value recorded. And percentage uncertainty is just we multiply by 100, so we got in percentage. So what was the distance recorded? The distance recorded was 200 and so distance recorded was 270. And what about the uncertainty in the measurement? This was 1 and this is also 1. So that will be 2. The value which we recorded here for the time was 2. And what is the uncertainty in the time? This was 0.02 and 0.02. So total uncertainty in time will be 0.04. And if we need the total uncertainty, so we will add them. Even if I don't use these numbers, I can just see the signs here that uncertainty always add. That's why A should be the right answer. So this is related to the first topic of the physics about the percentage uncertainty and uncertainty rather than the waves. Now, this question is about the waves, the four progressive waves on a stretched string, a graph A and B shown how the displacement D varies along the distance x, and a graph C and D shows how the distance vary with the time. The labels on the graph are intended for the wavelength, the time period, and amplitude. Which graphs are correctly labeled? Like in which graph amplitude, the time period is labeled correctly? You can use the chat to answer. So if this x-axis is a distance axis, like the length, so amplitude is marked correctly, but the time period is not marked correctly, because if the x-axis is the time scale, then only you can mark as a time period. That's why this is not correct. A is wrong. What is the mistake in B? If this is the x-axis, the wavelength is marked correctly, but amplitude is not marked correctly. Amplitude is the distance from mean position to the extreme. That is an amplitude. So A is not marked correctly. That's why A is incorrect. What about C? C, the x-axis is the time axis. So means the wavelength is marked on the time axis. So that is wrong. Amplitude is marked correctly, but this cannot be a wavelength. This should be a time. The correct answer for this one is D, because on x-axis, if you have a time scale, like if this is a time scale, so this will be the time period. On y-axis, if you have a distance scale, so this will be an amplitude. So the mistake in A was the time. This cannot be a time period. This should be a wavelength, because if it's in X, the mistake here is the marking of amplitude is not marked correctly. The mistake here, this cannot be a wavelength. It should be a time period. So which one is a wavelength? If this is an x-axis, if we label x-axis correct as a distance axis, so this should be the wavelength, because x-axis is a distance axis, like I have in centimeter. So if I have in centimeter, when I take a distance between the two successive crests, I will call that distance as a wavelength. But if x-axis was the time scale, like it was a time period in seconds, then the distance between the two successive crests or the two successive troughs, that will be the time period. So the mistake here, that this is not correct. The mistake here, this is wavelength is correct, but amplitude is not marked correctly. Mistake here that this should be a time scale, and this is the right. So the correct answer for this one was D. Is it clear? Is it clear to everyone? From the graph, if the yes, we can find the wavelength. If this was a time scale, by this measurement we cannot find the wavelength. That will be wrong. Then how we can find the wavelength? There's another method that using this time scale, I will find the time period. From time period, I will find the frequency. And from frequency, we'll use the formula V is equals to F lambda. So if I know the speed of the wave and I know the frequency, I can find the wavelength. So directly, the measurement cannot give us a wavelength, then calculation should be done. That is what they mean, that which labels are correct, like which labels we can directly find the wavelength. Question 5. So which statement about the sound waves in air at a constant temperature? If a temperature, because the speed of a sound depends on density of the medium. If a temperature changes, the density of the medium will also change. So the sound travel faster in a denser medium. But if it's constant temperature, it means that the speed won't change. So speed is constant. And if the speed is constant, what is the relation between a frequency and a wavelength? V is equals to F lambda. So V over F is equals to lambda. So frequency and wavelength are inversely proportional if the speed of a wave is constant. Amplitude is inversely proportional to velocity. No, amplitude and a velocity you cannot relate here, because the temperature, if amplitude is like, if a velocity is not changing, you cannot relate the amplitude. And plus intensity is directly proportional to amplitude square. That is a relation. Like amplitude can affect the intensity, not the velocity. So this is not a right statement. Frequency is inversely proportional to wavelength. That is a right statement. Velocity is proportional to wavelength. Yes, the velocity is proportional to wavelength. This is statement is correct, but not relevant to the question. If the frequency is constant, then speed of the wavelength is directly proportional to the wavelength. And again, the wavelength is proportional to amplitude. That's all. So this statement, I'm not saying this is wrong, but this is not relevant to the question because the constant temperature, so the velocity is not changing. As the velocity does not change, so speed of the wave is constant. And if a speed is constant, then frequency and the wavelength are inversely proportional. You have to recall two things. Intensity, when we define the term intensity, intensity is power acting on unit area or power on unit area. That is what we call intensity. So intensity is power divided by area. And area, as I mentioned, that will be 4 pi r square, because if we have a source with a power P is there, it is sending radiation or the wave in all the direction. So we want a intensity at a particular, because it's a power on a unit area. So it will, the source will always make a sphere. So this will be I, the intensity is equals to power divided by 4 pi r square. And what is the relation between an intensity and amplitude? Intensity is directly proportional to amplitude square. So the question is, how does the amplitude vary with the distance? So one formula, that intensity is directly like according to this, if we have a constant power, intensity is inversely proportional to r square. And another formula, intensity is directly proportional to amplitude square. So if I relate these two proportional relations, so I can say intensity square is inversely proportional to r square. Sorry, amplitude square is inversely proportional to r square, or I can say amplitude is inversely proportional to r. Means if we double the distance, amplitude will be half. If we triple the distance, amplitude will decrease by 3. If we quadruple, like 4 times the distance, amplitude will decrease by 4. So which relation is correct? A is correct. So remember, in these two formulas, intensity is directly proportional to amplitude square and intensity is inversely proportional to distance square. So when we compare the amplitude with the distance, so it is a simple inverse relation between them.